Good evening, everyone. Myself, Faaiz. I'm from AIIMS Nagpur. Today we are talking about alternating current. Okay. Today's chapter is alternating current. Let's directly discuss about first what. Yes. See, I have a magnetic field here. Okay, I have a magnetic field here. Its direction is it's going, yeah, inwards. Okay. And let me place a circular coil. Okay. It's a circular coil. This is a circular coil. This is a circular coil. Okay. This coil is rotating. This coil is rotating. Yeah. This coil is rotating with an angular velocity omega. Okay. Where the magnetic field exists. Easy. So the flux through the coil will be how much? Yes. Yeah, the flux through the coil will be we know that it is vector B dot A, right? So phi we can write like B A cos theta. Okay. See, this coil is rotating with the velocity omega. So can I write that the theta will be omega into t because changing angle will be omega into t. Okay. So I can write, yeah, flux phi equal to BA cos omega t. BA cos omega t. Okay, so we got the flux BA cos omega t. And we know that EMF is what? Yeah, minus d5 by dt. Okay, so just to differentiate phi, then we will get EMF. So EMF will be minus of d5 by dt or minus of d by dt of phi is BA cos omega t. Right. So if we differentiate, we will get, yeah, we will get B A omega. Then differential of cos omega is minus sin omega. So minus minus cancel each other. So minus, so B A omega sin omega t. This will be the EMF. B A omega sin omega t. Okay, this is the equation of EMF. From this equation, we will get equation of current I. Yes, so current I will be voltage or EMF divided by resistance. So if you do here, I equal to BA omega by R sin omega t. Okay, so this BA omega by R we can write as, yes, peak current I naught. So the equation for instantaneous current I will be how much? Will be I naught sin omega t. Okay, this is the equation for current. Instantaneous current I equal to I naught sin omega t, where I naught is BA omega by R. Easy. Yeah. Okay, so current having a sinusoidal graph. Yeah, current is having a sinusoidal graph, right? Because I equal to I naught sin omega t. So its graph will be like this, right? So if we want to take average value, see, this is 0, this is t. If you want to take average value from 0 to t, this will be plus, this will be minus, average value will be 0. So we cannot take average value full cycle, means 0 to t. So we have to take average value from 0 to t by 2. 0 to t by 2. So let me take current average. I average equal to, yeah, integral. This is the, yeah, this is how we find averages. Okay, like integral y dx by integral dx. Here integral I dt by integral dt. And from limits Yeah, from 0 to, I'm taking t by 2 because up to t will be 0. 0 to t by 2. Okay, if integrate these, we will get I average equal to 2 I naught divided by pi. Average equal to 2 I naught divided by pi. This 2 by pi is 0.63 I naught. Okay, so we got equation for average current I equal to 2 I naught by pi or 0.63 I naught. Okay, easy. Yeah. Next, very important, RMS value, IRMS. So what is RMS? Root mean square velocity. Here, root mean square current. Okay, root mean square current. So first we have to square, then we have to find mean, then we have to root it. Okay, so I'm not doing calculations. I'm not doing derivations here. But IRMS, we will get how much? Yes, IRMS is I naught divided by root 2, or we can write 0.707 I naught. This is IRMS. I naught by root 2, which is equal to 0.707 I naught. So I average and I average is 0.63 I naught, right? And IRMS is 0.707 I naught. Okay. IRMS is I naught by root 2, which is equal to 0.707 I naught. 1 by root 2 is 0.7. Okay, easy. So let me make a list. Okay, so first we saw I average. I average is 2 I naught divided by pi. Okay, and IRMS is I naught divided by root. And we know that peak value of current, a peak value of current is I naught, right? Peak value of current is I naught. Peak value of current is I naught. And our equation, instantaneous current I equal to peak value I naught into sine of omega t. These equations are, these four formulas are very important. Okay, easy. And let me, okay, see. Suppose, okay, we have given that current I equal to current I equal to current I equal to I naught sin omega t. We have to find what? Time to I naught. That is, see, the instantaneous current becomes I0 by root 2 to I0. You have to find out that time. And it is given that the time period is here t. How do we find this? For that, we can use phasor diagram. How? Okay, okay. See, I0 by root 2. Okay, suppose, let me take a point here. Okay, point. And radius of the circle is r. The coordinates and the angle made by horizontal is theta. The coordinates of this point P will be, we can write as r cos theta, comma r sin theta. Right. That is r sin theta means the y distance, right? R sin theta means this is r sin theta, the y distance. Okay. Suppose if y equal to r by 2, then theta will be how much? 30, because r into sine 30, r into 1 by 2. Suppose y equal to r by root 2, or y equal to root 3 r by 2. Yeah, we know theta will be 45 degree. Here theta will be 60 degree. Simple. Y equal to r sine theta. The same case, we can represent here y as I, current as a function of current. Okay, if you do that, okay, okay, it is given that first current is I naught by root 2. Okay, first current is I naught by root 2. I naught by root 2 means theta will be how much? Sine theta. When is sine theta becoming 1 by root 2 at 45 degree? 45 degree means pi by 4. So, yeah, first current is at, let me make here 45 degree. Second case, this is not 45, right? Yeah, 45. Yeah. Next current becomes I naught. I naught means, yeah, sine 90. So, reaches here. So, we have to find out, yeah, the current I root 2 to I naught. We have to find out this time interval. That is the time taken to travel pi by 4 angle. Right. Easy. Pi by 4 angle. So pi by 4 angle. Pi by 4 angle. So theta is, we know theta equal to omega t. And here the theta is, the rotated angle is pi by 4. Omega is 2 pi by t. We have to find out this time. Small t. Right. So we will get pi we can cancel. We will get t equal to, we will get t by 8. Yes. Okay. This is how you do questions, like using phasor diagram. Okay. So let me read the first question. An alternating current is given. An alternating current is given by the equation I equal to I1 sin omega t plus I2 cos omega t. The RMS current will be, okay. We know that the equation for RMS current is what? Peak current divided by root 2. So we have to find IRMS. For that, we have to get peak current. For peak current, we have given instantaneous current is given, right? Instantaneous current is I1 sin omega t plus I2 cos omega t. So we have to find the maximum value of this expression, right? That will be, yeah, something we have to learn. We have already learned from maths. What is that? Okay, for an expression a sin theta plus b cos theta. Okay, for this expression, the maximum value is root of a square plus b square, and the minimum value is minus root of a square plus b square. Okay, here is also the expression is in terms of a sin theta plus b cos theta, so its maximum will be root of a square plus b square. So here I know that the maximum current will be root of a square plus b square. Here a is I1, so I1 square plus I2 square. Okay, so we got I0, that is peak current. RMS will be this divided by root 2, or 1 by root 2 into root of I1 square plus I2 square. 1 by root 2 into root of I1 square plus I2 square. Which option? Yeah, option A seems to be the correct option. 1 by root 2 into I1 square plus I2 square all raised to 1 by 2. Easy. Yeah. Yeah. This is our next question. An alternating current voltage is given. Okay, this is 100 pi t. Okay, 100 pi t. 220 sin 100 pi t. Volt is applied to a purely resistive load of 50 ohm. The time taken for the current. But if I know time taken for the current to rise from half of the peak to the peak, half of the peak to peak. Again, phasor diagram. So we have already knew the concept. Simply, we have to find out time period. No, we have to find out time taken from, yeah, I naught by 2 to I naught, right? I naught by 2 means 1 by 2. Sin theta will become 1 by 2 at pi by 4. No, pi by, yes, pi by 6, right? Pi by 6. So, we draw a phasor diagram. So, I naught by 2 will be at pi by 6, that is at 30 degree. And I naught will be at 90 degree, right? I naught. So the traveled angle will be, means the time taken to, yeah, this angle is 60. That is pi by 3. So simple, right? We know that theta equal to omega t. Here theta is pi by 3, which is equal to omega is given, yeah. Expression omega, sin omega t. So omega is here 100 pi, 100 pi into t. Pi we can cancel. T will be 1 by 300. We can write like 10 by 3 into 10 raised to minus 3. Right. 10 by 3 will be how much? 3.33 millisecond. 3.33 millisecond. That is our option. D will be the correct option. Okay. Easy. Yeah. Yeah. Next. Yeah. Very important parts of this chapter, alternating current. See, first, let me connect resistance with alternating EMF. Right. So resistance R and current flowing through is I. Okay. And the voltage V is V0 sin omega t. And the current, the voltage along the resistance will be, yeah, IR equal to, we can write V0, V0 sin omega t, or current I will be V0 by R sin omega t. So see, voltage and current, voltage and current having same phase, that is minus of V equal to V naught sin omega t. We know that if the charge flowing is Q, the capacitance of the capacitor is C. Leading here,
Recording in
current is
progress.
lagging by 9. Okay, inductor is connected. Everyone understood? Okay. The next concept is, the next very important concept is, if we know the, okay, I peak current, peak value of current will be peak value of voltage divided by a term is known as X. This X is reactance. X is reactance. Okay. If resistor only connected, if capacitor only connected, if inductor only connected, or CL only connected, this reactance will be R. In capacitor it will be XC, which is equal to 1 by omega C, and reactance in inductor will be omega into L. Okay, okay, easy, yeah, easy. Yeah. Okay, next is very important. Which circuit? LCR circuit. LCR circuit. LCR circuit. LRC EMF. Okay, here we do like this, like we solve problems like this. Okay, I'm making this axis as current axis, so this is x-axis current axis. So we know that voltage along potential difference along resistance is same phase with current, so I can write like, okay. And we know that capacitance in capacitor, yes, current is leading, voltage is lagging. So here in inductor, current is lagging and voltage is leading. Okay, okay. So from this diagram, if VL is greater than VC, VL is greater than VC, we can make this, no, VR, this will be VL minus VC. So the net V net will be V net will be root of VR square plus VL minus VC whole square. Okay, and the net resistance is known as impedance Z, which is equal to root of R square plus capacitance reactance of inductor minus reactance of capacitor, that is XL minus XC whole square. Okay, easy. Okay, so yeah, this is our first question. Okay, these formula, these equations will get clarity when we solve problems. Okay, this is our first question. A sinusoidal voltage given V of t equal to 100 sine 200 t is applied across a pure inductance. Inductance is given, the current through the coil is. Okay, first thing we have to do is we have to find out current through the coil is. Okay, we have given, so we have to find out the current equation, right? So for that we have to find out peak value of current. We know that peak value of current will be, peak value of current is voltage peak divided by inductor only, so XL. Okay, so for that you have to find out XL. XL is L omega. Here L is how much? 2 into 10 raised to minus 2, and omega is how much? 500. 5 into 10 raised to 2, so this will be 10. XL is 10. So I peak will be, yeah, voltage peak is 100. So I peak will be, voltage peak is 100. Okay, 100 by 10, this will be 10. So the peak value of current is 10. Okay, this is an inductor, no? So in inductor we know that current is leading, right? Current is leading. So we will get current I as, in inductor, who is leading is voltage, current is lagging. So I equal to, I naught is 10 sine of omega t, right? Sine theta minus 90, we can write minus cos theta, so we can also write I equal to 10 into cos omega t minus. So here it will be minus 10 cos of 500t. Yes, yes. So which option? Option B is the correct. Okay. Next, in the adjacent circuit, the instantaneous current equation. Again, for instantaneous current equation, we have to find out the peak value of current, and we have to find out whether it is leading or lagging. What is the phase difference? Okay. So let's solve. This is a LR circuit. This is LR circuit. Okay, for LR circuit, we can draw like this, right? This is VR, this is VL. Okay, and this is R, this will be XL. Okay, we can write. So impedance Z will be how much? Root of R square plus XL square. Okay, so I peak will be the peak value of current will be, yeah, voltage peak divided by, that is given in question, impedance Z. Okay, for that we have given here resistance R is 100 ohm. Okay, and XL is, we know, L omega. Here it is, omega is 100, L is 1, so L omega is 100. So XL is 100. XL is 100. So Z will be root of 100 square plus 100 square. Z will be 100 root 2. Z will be 100 root 2. Okay, this is an LR circuit. So our equation will be equal to of omega t. Okay, this is LR circuit. So current is lagging. So my angle, how do we get this angle phi? Simple, right? That angle phi is this, no? This is VR, no, this is VL. This is VR, this is VL, and this is V net. So this angle is phi. So how do we get this phi? Simple. We know tan phi will be, yeah, VL by VR or XL by XL by resistance R. Here XL is 100 and resistance is also 100. So tan phi is 1. That means phi is pi by 4. So our equation will be I equal to root 2 sine omega t minus pi by 4. I equal to root 2 sine omega t minus pi by 4. Easy. So is root 2 sine 100 t. Omega t, here omega t is 100 t minus pi by 4. Yeah. Option B is the correct answer. Okay. This is our next question. Again, same type of question, just playing with the XL, XR, XL, HCR, VLVC, VR, phi. Okay. An inductance coil has a reactance. Inductance coil means, yeah, coil will have both L and R. Okay. Its reactance is given. That means XL is given as 100. No. Not X, not XL. Z, yeah. The combination root of XL square plus R square. Z is given as 100 total. When an AC signal of frequency 1000 separate the coil, applied voltage leads the current by 45 degree. The self inductance of the coil is. Now we have to find out L. It is saying that applied voltage leads the current. Applied voltage leading. Okay. We know that in LR circuit, voltage should lead, right? Because current is in lagging. So voltage leads current by 45 degree. So simple. By phasor diagram, this is VR or this is VL. And applied voltage leads the current by 45 degree. Yes, that is the V net making 45 degree angle. This is 45. This is 45 means, this is 45 means, this is 45 means, yeah, this 45 means tan 45 will be VL by VR. That is VL by VR equal to 1. That is VL equal to VR. That means L omega equal to R. Or we can write XL is equal to R. XL equal to R. So impedance is root of X. So XL is equal to R. So root of XL square plus XL square. That is XL root 2. And impedance is given in question how much? 100. So 100 equal to L omega root 2. Okay. Or we can write L omega as 100 by root 2. Okay, L omega. Omega is given, not omega is given. Omega like L into we can write 2 pi f, right? Omega we can write 2 pi f. 100 by root 2. Frequency is given 1000. So by substituting this 100 by root 2 by 2 pi into 10 raised to 1000. Okay, so we will get how much? So if we solve this, we are getting 1.1 into 10 raised to minus 2. 1.1 into 10 raised to minus 2. So which option? Option A is correct option. 1.1 into 10 raised to minus 2. Okay. Yeah, this is our next question. A circuit connected to an AC source of EMF equal to E naught sine of 100t, which t in seconds gives a phase difference of pi by 4 between the EMF E and current I. Which of the following circuits will exhibit this? It's given that EMF and current having a phase difference pi by 4. Okay, EMF and phase difference and voltage having a EMF and current having a phase difference of pi by 4. That's given. Have to find out which circuit. So two combinations like RL, then RC. So RL and RC. Suppose if it is RL, R is here, XL is here, and the yeah, phase difference is pi by 4 means 45 degree tan 45 will be 1. We can write XL equal to R, right? And if it is RC, then R will be like this, and XC will be like this. We can write XC equal to R. Okay, so we have to find out from these combinations, where it is getting XL equal to R or XC equal to R. Okay, let me do the last option. The last option is R is 1 kilo ohm and C is 10 microfarad. Right. So if we do that, XC is how much? 1 by omega C, or 1 by omega is given as 100, and C is 10 micro. 10 micro means 10 into 10 raised to minus 6. So this will be 10 raised to minus 3. 1 by 10 raised to minus 3 is 10 raised to 3. So 10 raised to 3 is 1 kilo. So 1 kilo ohm is resistance is also 1 kilo ohm. That means XC equal to R in last option. Okay, in this option, A option, B option, 3 option, that won't be equal. So which will be our answer? Option D. Let me just solve with this B also. Suppose B is L is given 1 mH, 1 millihenry. So XL will be 10 raised to minus 3. 1 millihenry into omega is 10 raised to 2. That is 10 raised to minus 1. 10 raised to minus 1. But it is 1 kilo ohm. Okay, this won't fit. Here it is given 10 millihenry. 10 millihenry means 10 raised to minus 2. 10 raised to minus 2 into 10 raised to 2. That will be 1. No. Here. So option is D is only the correct option. Okay. Okay. If inductance L is equal to 40 millihenry and if the voltage is 10 sine 3140 is applied to the circuit, the current in the circuit is given as. Again, very simple. Okay. First, we have to find out peak value of current. For peak value of current, this is an LC circuit. We have to find out impedance. Impedance will be root of XL square plus XC square. Right. So XL will be how much here? XL will be L omega. How much? L omega is how much? L omega. L is 40. L is 40 into How many questions are remaining? 1, 2, 3, 4. Okay. So we have to make little fast. Anyway, L omega is okay. 40 into 10 raised to minus 3. Omega is 314. Right. So we will get how much? And xc will be 1 by c omega. So that will be 1 by 314 600 micro. So 10 raised to 4. So we will get xc. So if we do z impedance equal to root of xc square plus xl square. Right. And if xl is greater than xc, current is current is lagging by voltage. We say greater than xl, we can say current is lead by 90 degree. So accordingly, sections. It will be lengthy. You understood the concept, right? XC. Yeah. And if in this question, if x is greater than xc, is lead. So want to at the last, okay? That's a beautiful question. Find the peak following circuit. Okay, before that, what is resonant frequency? Resonant frequency means the frequency where impedance is minimum. Impedance is minimum. You know that impedance z equal to root of r square plus xl minus xc whole square, right? If xl is greater than xc, this is impedance. So frequency happens at impedance gets minimum. It's minimum. Suppose if we want to get impedance is minimum, for that XL minus XC part should become 0. For that, yeah, XL should equal to XC. That's the condition for resonance. So XL is L omega. This is 1 by C omega. So omega square equal to 1 by LC, or omega equal to 1 by root LC, right? Or time period T will be 2 pi into root of LC, or frequency will be 1 by 2 pi into root of LC. 1 by 2 pi into root LC. Okay. Any doubt? No doubt. So here it's saying that find the peak current and resonant frequency of the following circuit. Resonant frequency. So resonant frequency, what is the formula of resonant frequency? The formula of resonant frequency is, we all know the formula of resonant frequency is 1 upon 2 pi root of LC. Question given that 2 pi root of L is how much? L is 100 millihenry. So we can write 100 into 10 raised to minus 3. Capacitance is 100 microfarad. 100 into 10 raised to minus 6. So here what we can do, 10 raised to minus 6, 10 raised to minus 2, 10 raised to minus 2, 10 raised to minus 3, 10 raised to minus 5, 10 raised to minus 5. So 10 raised to minus 5. 10 raised to minus 5, I can write 10 raised to minus 5. So if it comes to numerator, it will become 10 raised to plus 5. So 10 raised to 4 into 10, I can write. So this will be 10 raised to 4 means root of 10 raised to 4, 100. So 100 root to 10 divided by 2 pi. We know that pi is 3.14, right? So pi square approximately equal to 10, and root and root 10 is pi. So root 10 is pi. So pi get cancelled. 100 by 2, 50 hertz. So the resonant frequency is 50 hertz. So option A and D. Next, we have to peak. Okay, peak current. Question is not saying peak current at a resonant frequency. So we have to find out peak current in which way. First, we have to find out impedance. How do we find impedance? That is equal to root of R square plus XL minus XC whole square. So if we do that, we are getting option A. So which option is correct? Option A. Okay. Yeah. This is the next question. A sinusoidal voltage peak value is given, voltage peak value given, angular frequency given, LCR circuit. This is LCR circuit. For R is 5 ohm, L is 25 millihenry, capacitance is 1000 microfarad. The total impedance and the phase difference between the voltage across the source and the current will respectively. So to find out impedance. For impedance, first let me, what is XL? L is L omega. L is 25 and raised to minus 3. Omega is 283. No. That is peak value of voltage. Omega is 320. Angular frequency is 320. This will be how much? 320, 320, 25 into 328 into 324. So approximately you'll get 8. Okay. XC will be 1 by C omega. So 1 by 10 raised to minus 3. 10 raised to minus 6 and 10 raised to 10 raised to minus 3 into 320. This is approximately we will get 3.1. Okay. So we got XL 8, XC 3.1. And R is given as 5 ohm. R is given as 5. So this is actually condition XL greater than XC. Okay. For the whole circuit, which will lead? Yeah. Voltage will lead because XL is greater than XC, right? Yeah. So our impedance will be root of R square plus XL minus XC whole square. So which will be root of 5 square plus 8 minus 3.1. So 8 minus 3.1 approx 4.9, then I can take it as 5. So root of 5 square plus 5 square, it will be 5 root of 2. 5 root of 2 is 1.4. 5 into 1.4 approx will be 7. So impedance we got 7. Okay, impedance we got 7. Okay, next we have to find out phase difference, right? So this circuit is like this, no? XL is greater than XC. So this is R 5 ohm here. XL minus XC also 5. So simple, this 5 will be 45 degree or pi by 4. So we got everything right. Yeah, so our answer will be B option, 7 ohm and 45 degree. Okay, it's very easy question, right? Yeah. This is our next question. In an LC oscillator, if values of inductance and capacitance becomes inductance and capacitance becomes twice and 8 times respectively, then the resonant frequency of oscillator becomes x times its initial resonant frequency omega naught. The value of x is very simple. So it's all about resonant frequency. So simple, what is the equation of resonant frequency? Resonant frequency omega naught. What is the equation of omega in a resonance? Yeah, 1 by root LC. So omega is initial resonant frequency omega naught. So omega naught equal to 1 by root LC. Okay. Question they're saying, yeah, inductance they doubled. So new inductance is 12. And capacitance they 8 times, no? Capacitance 8 times. Yeah, 8 times. Yes. 8 times. So the omega dash, the new resonant frequency will be 1 by root of LC, 2L into 8C. So we can write as 1 by root of 16LC. So it will be 1 by 4 into 1 by root LC. 1 by root LC is omega naught. So omega dash is omega naught into 1 by 4. So x times, right? X will be 1 by 4. X will be 1 by 4. X will be 1 by 4. Okay. This is our last question. Saying an inductor of inductance 2 microhenries connected in series with a resistance, a variable capacitor, and an AC source of frequency 7 kilohertz. The value of capacitance for which maximum current is drawn into the circuit is 1 by x farad. What the value of x is? See, maximum current is drawn into circuit. That's a keyword. Maximum current means you know that I is V by Z, right? Impedance. So impedance should become minimum. Okay. Impedance should become minimum. So impedance should become minimum. So impedance at minimum means which condition? Yes, resonant condition. Resonant condition, right? So at resonance we know that XL equal to XC, then only Z become R, right? Root of R square plus XL minus XC whole square. XL equal to XC, then XL minus XC 0. So XL equal to XC. So XL will be L omega, which is equal to 1 by C omega. But here omega is not given, it's given in the terms of frequency. So you can write omega as 2 pi f. So L into 2 pi f equal to 1 by C into 2 pi f. Okay, I have to find out the value of capacitance. We have to find out the value of capacitance. So we can make an equation for capacitance as C equal to 1 by root of 1 by no root 4 pi square f square L. Okay, is equal to 1 by 4 into pi square into frequency is given for 7 kilohertz. 7 kilohertz. 7 into 10 raised to 3. So its square will be 49 into 10 raised to 6. And inductance is given 2 microhenry. This will be 2 into 10 raised to minus 6. So get 10 raised to 6 and 10 raised to minus 6 get cancelled. So 1 upon 4 pi square into 9 into 2. And saying we can take pi as 22 by 7. Pi as 22 by 7. So equal to 1 by 8. 4 into 8 pi square. 22 square by 7 square into 49. So 49 is 7 square. So we can cut 22 square. And this will be 1 by 8 into 22 into 22. What is 22 square? 22 into 22. 484 into 8. 2, 3, 6, 3872. So we got capacitance C as 1 by 3872. Okay, 1 by x farad. So x will be 387. X will be 387. 7, right? So x will be 3872. Okay. So yeah, questions are over. Yes. So next we have left something, no? Some calculation. I think. Okay, here. Here, see, we have to find out peak current. For peak current, first we have to find like Z. So Z will be root of R square plus XL minus XC whole square. Okay. R is 120 and XL is L omega. L is given as 100 into 10 raised to minus 3 milli. Okay, omega is how much? Omega is how much da? 30 sine 100 t. So 100. Where are we? Yes, 100. 10 raised to 2. This will be 10 to 10 raised to minus 3. Wait, this will be 10. Right, this will be 10. And XC is 1 by C omega. And C is 100 microfarad. So 100 in 10 raised to minus 6, 10 raised to minus 4. Omega is 10 raised to 2. So 1 by 10 raised to minus 4 into 10 raised to 2, 10 raised to minus 2, that is 100. So X is 100. Right. XL is inductance is 100 milli. So 100 into 10 raised to minus 3. Into 10 raised to 2. 10 raised to 4, 10 raised to minus 3. 10 only, yeah. So Z. So XL minus XC will be XL minus XC. So here is XC is leading. So 100 minus 10, 90. 90. So Z will be root of 120 square plus 90 square. 120 square plus 90 square. 120 square plus 90 square. How much? 12, 9, 81, 25, right? Yeah. Yeah, so 15. Yes. It will be how much? 150. Right, 150. But we find out peak current. For peak current, yeah. P peak is 30. So current peak will V peak divided by Z. V peak is 30. So 3 by 50. 3 by 50 means 1 by 5. 1 by 5 is point 2 ampere. 0.2 ampere. So yeah, so mathematics calculations.